Hey guys, alright, so hopefully you just watched my video on setting a fixed RPM on a Wilo Maxo. So what we're going to do now is we're going to hit different points of RPMs that correlates with the curve, and we're going to plot a system curve. So just for those of you who don't know, this is what a pump curve looks like, and this is the pump curve for this Wilo Stratos Maxo 1.25 by 3 by 15. And what we're going to do is pick different RPM points and then plot a system curve. Just anything to show you where you're at and to see how it reacts with my system. For those of you who have not seen the system, this is my little hydronics trainer that has a series of balance valves on it, point and no pressure change fill, my little demo head for connecting it to a Lochinvar boiler, as well as my ultrasonic flow meter that I use to compare to what the pump says. All right, here we go. So let's just pick some random RPMs off the curve. So we're at 750 right now, and let's bump it up to 1700 RPM and see where our flow and head's at. So currently we're at 750. We're getting around, wow, it's bouncing all over at this low. Probably because there's not enough head pressure to complete the loop, or it's struggling with it. So let's bump it right up to 1400. We'll do that by pushing our knob, spinning up to 1400, enter. And then we'll let it level out and see where that puts us. So our RPM is speeding up to our 1400. We're getting about 4.2 feet of head resistance. And we're also getting about 7 GPM. So my next target is going to be, I'm going to bump it right up to, let's go to 2000. So back to our home screen, push our big magic green dial, spin it up to 2000. Ooh, passed it. Boom. And we'll watch it pick up speed. Now we're at about our 2000 RPM. Looks like our flow is leveling out. 10.1, 8.5 feet ahead. Get an idea what my flow meter says. 10.6. Right in that range. 10.19. Bouncing around a little bit. And then let's go one more time. Let's go all the way up to full speed. And one thing you'll keep an eye down here is you'll notice that this pump will recognize when it maxes out its pump curve. So click our big green button, all the way up to max RPM, hit OK, bottomed out our curve. But let's see exactly where that's at. So we're chasing up to our 2600 RPM. You can actually hear the pump a little bit. Now, due to certain hydraulics, it may not actually quite get there, but it's doing its best. So we're at around 13 gallon a minute, 12.5 feet ahead. And we'll look at our little ultrasonic flow meter, right in the same range. So what I'm going to do next is I'm going to do them same points, and I'll do it on the app, and we'll plot out the points on the app, and then we'll do it manually on the piece of paper, plotting out the system curve. Okay, here we go. If you just watched the front half of this video, you'll know that I started at about 750 RPM. For some reason, when I did it on the app, it wouldn't let me go past its programmed minimum set point, so I went with 760. Close enough. And you can see that the pump is fighting, probably to complete the loop. It's not quite big enough or providing enough head pressure to complete my little circuit here and get through my point and no pressure change and everything. So I do believe the next RPM I went to was 1400. So we'll go back to settings, pump setting, and we'll bump it up to 1400. Next, and we'll go back to my monitoring. Now we bumped it up to 1400, and we're stabilizing out here. And we'll plot this point on the system curve. I'll do screenshots as I go here. We'll scroll up, 1400 RPM. That puts us at about 7 GPM and 4 foot ahead. Another screenshot. Now let's go back and we'll bump it up to 2000. All right, go back to our pump curve. Here we go again, flowing head. Another screenshot, and just as a reminder, my bypass is wide open if I didn't mention that before. Now we'll go back to the full 2600, which is the max RPM on this. You can see right underneath the set point speed. 2600, next. Back, monitoring, and you can see we're right at the top of the pump curve again. Do a screenshot, and you can see right at the bottom here, Q limit at max pump curve. Remember before I showed you on the screen how it illustrated that. Here it does in the app also, which is pretty cool. Alright, so we'll plot those points on the pump curve next. Let's review the screenshots. We had our first RPM at 760. You can see our duty point is down in the left-hand corner of the screen. We originally started at 2600 RPM, which gave us 12.8 GPM and 12.5 feet ahead. We also did 2000 RPM, which was about 10.1 to 8.5. You can see how the flow and the head are matching on the curve as it works its way down. And then after the 750, we're at 1400, which gave us about 7 GPM and 4.3 feet ahead. So to see the system curve all in its entirety, flip over to our little piece of paper here. And you can see, if you plot out those points, you can see your system curve. And this is for my little hydronic helper with the bypass valve open. What this could do is, again, find your duty points along a system curve. Say if you were down here at your operating in your system, and there was another pump that might have fell in this range. Or back in the day, we used to use that range to trim an impeller. You would have different impeller curves and horsepowers along here. Now we have ECM motors and freak drives or variable frequency drives built right into them with all these cool bells and whistles. What you could also do is if, say, you wanted to add another zone to your system, you could see exactly how much pump you had left. And you could calculate the flow and head that you needed for your new zone or side zone and decide whether or not you had to upgrade your pump. All right, guys, I hope that made sense, and I hope it's some valuable information for you. I'll keep doing these as I get better at them. Thanks.